Hi everyone, my name is Chris Peterson, Director of Product Management here at Salesforce for Apex. And today I'd like to talk to you about Apex Invokable Actions. If you're not familiar with the Invokable Action framework, all you need to take advantage of it is an Apex class that contains a static method annotated with invocable method. As part of this annotation, you're required to specify some additional parameters like a label for showing in declarative tooling, a description, and optionally a category. Once you've done that, your Apex action is automatically exposed in the flow and process builder. This is wonderful because it means that you can augment the power of declarative tools with Apex code fairly seamlessly. And on top of that, you also get a free REST API created by the Actions framework for doing this. So if you ever built an Apex REST service and then a separate Apex service and then tried to build something that bridges that into declarative tools, you've probably ended up with a large volume of code specifically trying to handle the unique aspects of each of those entry points. With the Invokable framework, you don't need to do that. Really, you get one action that can be interacted with across all of the Salesforce platform features. So, what I'd really like you to take away from the session today is that you should design with invocable actions in mind, especially if you're starting a greenfield project. They may not always be the perfect fit for your use case, but you should absolutely consider them and consider them as the default option unless you have a reason not to. Let's take a look. Here, you'll see an Apex class that I've written already called Sanitize Update. You see our invocable method annotation on here on a static method. You see our label, that it's the SObject update sanitizer. We have provided a description as well as a category. And then we have our static method, which takes a list of SObjects as input and returns a list of SObjects as output. The real core of this method is calling the security strip and accessible method in Apex, which, being fairly new, if you're not familiar with it, takes a list of SObjects as the input and returns a stripped down clone of those that has had field and object level security automatically enforced. So if you passed in something like a list of cases that were generated in a system mode feature that contained fields the running user didn't have access to, strip and accessible would handle that for you. It would return a stripped down version of those cases that only has the information the user should be able to, in the case of this action, update. So that's exactly what this does. And really, we're looking at 1-2 lines of logic beyond the boilerplate here and some additional logging we've added for debuggability. So let's see how useful 2 Apex statements are in the context of flow, how much value they can actually bring to the table. As we jump over to our flow builder, you'll see the name of our flow, self-close case, gives you a hint at what we're doing today. Our business problem is that we'd like to allow end users through our communities to close their own cases. We don't want them to be able to update the status in any other way. We don't want them to be able to set the status to escalated. We don't want them to be able to close somebody else's case. We only want it to be their own case, and only if a custom field called can self-close is set to true. And you notice one interesting thing about this flow, if I dive into the flow properties, which is that much like Apex code, this is running in system context, specifically with sharing enforced. So this flow, using some fairly new features that have been added in the last couple releases, runs in the same type of security model as an Apex class that's defined with sharing, which means it can do things that the end user can't. And that's what we'd like to take advantage of here today. So the very first thing we do is we fetch our case. If you're not familiar with this in Flow, the context record is always passed in as the special record ID variable. So the first thing we do is run a SOCL query on case to find our case. We then check that field, allow self-closure, and if the answer is no, redirect the user to an error screen. If the answer is yes, then we invoke our new Apex action. And this does something interesting, which is if the user doesn't have access to edit cases at all, or specifically update cases because we passed in update in our action, it'll generate a fault. So you'll see this fault connector pointing back to our no access screen. So this is doing a material amount of security enforcement. So we know that the only thing that's going to be updated on this case when we get over to this update records call is what the user can do in user mode. So we're really enforcing all of the best practices of the Salesforce security model through this one action that really breaks down to 2 Apex statements. Glorious. So let's continue the rest of our flow and then see it in action real quick. We see our assignment that the case status is set to closed. The running user couldn't do that, but we're in system mode, so that's fine. Show the user a screen, letting them know the case has been closed and asking them for a final comment. And then we create that comment. Simple, elegant, wonderful. So let's run through it in the flow debugger. Here I've created a case where I've lost my phone. I'm going to copy the record ID, go over back to the flow builder, and debug it. So here we are in the flow debugger. Manually specify my record ID, which I wouldn't have to do normally, but in the debugger I do. And in just a second, we'll see that because I have access to update cases, my case is now closed. We passed all those access checks. All done. So we hop back over to our case. Look at that. Our case is closed, and our case comment got posted. Well, we learned that system mode is wonderful for letting you do things that the user couldn't normally do, but you have to be really careful with that extra power. We were reminded of things that Apex developers should already know, which is that with great power comes great responsibility. And we showed you a new technique for really quite easily making sure that you add that responsibility into your flows when they run in system mode. So no matter whether you come from a background of declarative or programmatic, what we'd really like you to remember is mixing the two gives you something so much greater than the sum of its parts.